So this problem is a little trickier. We want to find the polar intersection of the curves r equals 20 sine of theta, r equals 20 cosine of theta. Now they've very kindly given us the points of intersection right from the start, which is very nice. So we can see that the intersections are 0, 0, which is of course down here, and 10 square root of 2 pi over 4, which is along this line. So we can see that this must be along the ray pi over 4 coming up. And therein lies the difficulty. So r equals 20 cosine of theta is this green curve right here, right? This green circle. And r equals 20 sine of theta is the blue circle. So which one's the outer portion, right? Keeping in mind, polar area is always derived from or generated from looking back at the pole. That's how it works. Let's go look at it in Desmos really quick. So when we look at the area of a polar region, we're bringing it back to, right, it's areas of sections coming around, but always generating back to the pole. So you're taking that region back to the pole like a little piece of pie, right? So if we look at our particular region, who's the outer one depends on where we are. So for this portion of the curve, so we're generating back, right? So we're talking about this region right here. There's the region that is within both curves, right? So that's the region that lies within both curves. So for the first portion, it's from 0 here to pi over 4, but it's the blue curve that we want to use, right? So the blue curve is our generating function. And then for the next portion, right, so, and it's really the blue curve minus nothing, right, because it's that region right there. And then for the next bit, it's the green portion, right? So this one actually seems originally like it's one minus the other, but it isn't. There isn't an outer and inner, there's just an outer. Let me show you in Desmos really quickly. Okay, so for this portion of the curve, right, for all the way up to pi over 4, right, from 0 to pi over 4, it's going to generate that area back, right? So it's just going to be from there to there, right? So that's going to go from 0 to pi over 4, and that'll get you that portion. And you can see it's not subtracting anything, right? It's just coming back. So there's little sections coming back to the pole. And then the other portion is on the other side, and that's the 20 cosine of theta. There, only the green part matters, right? I could even color code it here. So for this portion, the green curve is all that matters. And for this portion, the blue curve is all that matters, right? As crazy as that might seem. So if I want to find the area of the region altogether, then what I need to do is find the area of each of those two separate regions and add them up. Or I could be crafty about it, but give me 1 second. Okay, so if I draw that tear shape one more time, kind of closer for myself. So from 0 to pi over 4 would get me this region, right? So over here, 0, up there is pi over 4. So the area will be the area of the blue curve from 0 to pi over 4, which would be 1/2 from 0 to pi over 4. That blue curve is 20 sine of theta, and of course we square it, d theta. Okay, now the other side of it, coming down the other end, I'll go this way, right, is from pi over 4 to something. We'll have to figure that out. And it looks like that, right? And that's that piece kind of zoomed in on. So where is that hitting? Where do they touch, right? So they gave us one intersection. They told us 0, 0 and pi over 10 square root of 2 pi over 4. So there must be another one where sine and cosine are equal to each other. So let me write this out. Plus, and then it's going to be another 1/2 for this region. It'll be from pi over 4 to something, right? Because that'll sweep us pi over 4 out to here. Pi over 4 to something, and then it'll be 20 cosine of theta squared d theta. So all I have to do is figure out what this piece is. Okay, well, what must that piece be? So to find what this is, I must let the green curve be equal to 0, right? So 20 cosine of theta is equal to 0. That means the cosine of theta is equal to 0. That means that theta is pi over 2, which is not entirely surprising considering the symmetry of this graph. So 0 to pi over 4 gets you here. Pi over 4 to pi over 2 gets you here. So that means that that top piece of my integral has to be pi over 2. Now, that's all well and good, and it's correct. However, we could be a little bit wise about this. I mean, think about it. Because of symmetry on this thing, we don't really need to do both pieces. We know that if we just do the blue portion and multiply it by 2, we'll actually have both of them. So I could say this is equal by symmetry to 2 times, and I could use either one of these actually. I could do the green portion or the blue portion. But of course, I'm going to do the blue portion because of the 0. We always know that 0 is a lot easier to work with than pi over 4 and pi over 2, right? Although pi over 2 is not bad. And I'm just going to multiply this out right while I'm here by symmetry. You don't technically have to do this, but it's a lot easier if you do, right? I mean, why do 2 integrals when you can get away with just 1? Okay, so 400 times 2 times 1 over 100 makes 400. So that's just going to be 400. And then I'm going to integrate sine squared. But we are long past the point of having to do something like that by hand. We have a full integral table that we got in chapter 8. Let's use it. So sine squared u equals 1/2 u minus sine u cosine u. Now, of course, the sine squared, the u is just theta for us, right? This is a really simple problem. So we're going to use formula number 51. So let me write that over here. Just so I can see it while I write real quick. So this is equal to, now remember these crossed off, so they kind of went away because 2 times 1/2, and I've got my 400. So now by formula number 51, because if I'm going to use a formula in the table, I always have to state. So that's equal to 1/2, and then actually, I'm just going to write it in blue as well, just to kind of keep my color coding consistent. So 1/2, and then it'd be u, which in my case is theta, minus sine of theta cosine of theta. I'm going to take that from 0 to pi over 4, like that. All right, so that 1/2 came out of the formula. It's not this 1/2. This 1/2 is gone because it canceled with the 2, right? So they're gone, but this is from the formula. All right, so now I'm going to bring the 1/2 out, right? I brought the 400 out. I'm going to bring the 1/2 out. That makes 200. And then for theta, I'm going to put in pi over 4 minus sine of pi over 4 cosine of pi over 4. There's pi over 4 in, minus, and then 0 minus 0, because the sine of 0 is 0. So it's 0 times 1, right, which is 0. All right, so this is all gone. That guy's 0. That's why we use 0, because it usually makes a lot of things disappear. And so I'm left with 200 times pi over 4 minus, well, the sine of pi over 4 and the cosine of pi over 4 are both 1 over the square root of 2. So that would be 200 times pi over 4 minus 1/2. So I could technically either distribute the 200 or I could factor out the 1/2, either way you want to do it. So it's 50 pi minus 100 if I distribute centimeters squared. Or if you want to factor out the 1/2, it's 100 times pi over 2 minus 1. centimeters squared. That works too. I mean, depends on which way you want to go. I think distributing by 200 is a little easier. All right, so that's what I think it is. I can come up with a decimal for that. Let's grab decimos real quick, and let's also verify that our integral is correct. So when I'm in here, let me zoom out so we can see this picture better. If I want to find 50 pi minus 100 is easy. If I want to take the integral, well, let's see. If I want to double check this was really equal to what I originally said it was, I can do that. 0 to pi over 4, and it would be 20 sine, I'm going to use x, but just because it's easier for decimals to handle, right? Dx plus another integral. As a matter of fact, I can just copy and paste the whole thing. And this one's going to go from pi over 4 to pi over 2, and it's 20 cosine of x. And ta-da! And that was the original integral before I divided in half and cut away and only did the blue portion and everything. And sure enough, they are equal. Hooray! Oh, check that number. It was 57.08.